Just like dimensional analysis, percent reaches across so many domains on the RD exam. Sometimes percent is right there in the question. Like, for instance, what percent of a formula is made up of fat? Or what percent saturated fat is a patient consuming? In those cases, you're using the full percent equation, that specific outcomes divided by total outcomes times 100. But other times, the question is asking for per, like price per meal or trays per shift, patients seen per dietitian. That word per is doing the same work that percent does. It's a ratio. It's actual outcome over total outcome, but you just don't multiply it by 100. Remember, percent means of 100, so per is the exact same equation, we just don't multiply it by 100. And we see this again and again on the RD exam. Seat turnover, cost per meal, even profit margins. They're all working from the same relationship, one value divided by another. Even BMI uses this structure. You're dividing weight by height, specifically kilograms per meter squared or pounds per inches squared, depending on the version that you use. And there's a relationship between kilograms and pounds in equivalent statements. And there's an equivalent statement between meters and inches, right? There's 2.2 pounds in a kilogram and 39.4 inches in a meter. Those are equivalent statements, and they use the exact same method, dimensional analysis. Or you can memorize both BMI equations. That's up to you. The fact is, BMI is a ratio. It uses the exact same equation setup as percent and all of our per equations. And then we have weight change. A change is still a percent equation, but here we're comparing two values over time. Current weight versus previous weight. It's the change divided by the original weight times 100. The weight change equation is an important one to know because it's clinically meaningful in the malnutrition diagnosis, which we'll cover in depth in Module 3. But the point is, whether we're talking about a formula calculation, a budget report, or a nutrition diagnosis, it all comes back to that same structure. And now that we've seen how percent shows up on the RD exam, let's talk about how we'll actually solve these problems again and again. The first and most important strategy is to understand the algebra foundations of how to undo an operation. This is what you learned in 7th grade and 8th grade math, through 9th grade and 10th grade math. You probably reviewed it in college. It is such an important skill. If we're solving for percent, we take the actual outcome, divide it by the total, and multiply it by 100. That gives us the percent. But if the question, say, gives us percent and asks us to work backwards, like for instance to solve for the specific outcomes, we need to do some algebra. And to do that, we need to reverse the process by using opposite operations. Let's work through this. If percent equals actual divided by total multiplied by 100, and the problem asks us to solve for the actual outcomes, we need to undo this multiplication first. To undo multiplication, we would need to divide both sides by 100. When we do that, 100 cancels out. And what we're left here is our percent as a decimal equaling our actual outcomes. Instead of specific, I've used actual here, divided by t for total. To solve for this actual outcomes now, we need to move total outcomes over. Well, actual outcomes is being divided by total outcomes. So we need to undo division. We would need to multiply both sides by total outcomes. When we do this, total outcomes cancels out. And what we're left with is total outcomes times our decimal percent, our actual outcomes. Okay, but maybe the problem wanted you to solve for total outcomes. How would we solve for total outcomes? Well, to solve for total outcomes, we need to undo this multiplication again. And the opposite of multiplication is division. We would need to divide both sides by our decimal percent here. And when we do that, the decimal percent cancels out, and we'll be left with our equation that total outcomes is equal to actual outcomes divided by our decimal percent. This idea that multiplication and division are opposites and that addition and subtraction are opposites is the core of algebra. And it's what will allow you to move fluently through percent problems. This is an absolutely foundational skill that you need for success on the RD exam. And once you understand how to undo these operations, we can also use a second strategy that will help us solve these problems, cross multiplication. I personally really like cross multiplication, but you don't need it if you can use these undo the operation algebra foundations. However, when we're working with numerators and denominators, I like to use cross multiplication to make sure that I don't mess anything up. When you cross multiply, you're taking each numerator and multiplying it by the denominator across from it, diagonally across the equal sign. It allows you to eliminate the fractions and rewrite the equation in a form that's easier to solve. But it won't work if we have another value on one side of the equation. So we do actually need to undo the operation to get rid of this 100. We have to undo multiply, meaning we need to divide both sides by 100 here, which is exactly what we did on the left side of the screen. And we're left with 0%, point percent, decimal percent, is equal to our actual outcomes divided by our total outcomes. Now, I went ahead and put 0.p over 1 because any number is just itself over 1, though we could have written it this way, point percent is equal to actual outcomes over total outcomes. In cross multiplication, you look across diagonally over this equal sign and you multiply this way. So instead of working with two fractions now, you have one equation in a linear form that doesn't have any fractions. And we can solve this using the algebra that we talked about earlier, because this equation is exactly the same as this equation that we have written right over here. Total outcomes multiplied by decimal percent is equal to our actual outcomes. Cross multiplication is a skill that will help us simplify our math if you want to, because it still relies on recognizing how to undo the operation, and that, again, comes from algebra. Now, I do want to introduce a third strategy. It's called the triangle strategy, but I want to be honest with you, I don't recommend relying on the triangle as your primary method because it only works when the setup is clean and direct. I find it can be more confusing than helpful, particularly for those who aren't strong in algebra yet. But as your skills develop, it can be a helpful guide, and it's definitely helpful as a quick check. So here is how the triangle method works. For any ratio equation, that is, where one thing is equal to a fraction, you can build yourself a triangle where your single variable goes in the bottom left, and then your fraction goes in the top and the bottom. So here's my percent equation, where percent is equal to our actual outcomes divided by our total outcomes. The way this triangle works is that you cover up the variable that you're solving for. So get your finger ready. Cover up that percent with your thumb. What's left? Actual over total. That's the percent equation. But what if we're solving for actual values? Get that thumb. Cover actual. What's left? Percent multiplied by total. The vertical bar is a multiplication symbol, just like how a parentheses means multiplication. And what if the problem asks you to solve for the total outcomes and it gives you the actual outcomes and the percent? Cover total with your thumb. And what's left over? Actual over percent. This triangle is handy in checking your work, but being able to solve for the numerator or denominator in a ratio equation, like percent, relies on you being able to undo the operation, cross multiply if needed, and checking your work with the triangle. We'll do some practice problems to make sure you can follow these steps, and as always, I recommend you pause the video whenever a new problem appears. You try it first, and then you press play, and we walk through the solutions together, because we are in this step by step.